All right, this is another example of a confidence interval with means. So here's the situation. The Helena Traffic Department is worried about the traffic on Euclid Ave, so they decide to do a quick test. A police officer hiding behind a tree records the speeds of 23 randomly selected cars and finds an average of 31 miles per hour with a standard deviation of 4.25 miles per hour. Find a 95% confidence interval using the t-distribution. So let's build these things in Excel here. So we've got a mean of 31, a standard deviation of 4.25, the degrees of freedom, wait a minute, sample size is 23. Now degrees of freedom. Remember, degrees of freedom is calculated by doing sample size minus 1. So that is sample size minus 1, that's 22. And now if I want to do a 95% confidence interval, my t-score, or my critical t-value, comes from the t-distribution, and I do inverse t. Now let's think about it. 95% has 5% remaining in the tails, which means 2.5% remaining on the left-hand tail. So I've got 95% plus 2.5% is my probability, comma, my degrees of freedom. Now, of course, I could have just typed in 0.975 and got the same thing. Okay, so there's my t-score. If you recall, on the t-distribution, if I'm down here at 22 degrees of freedom, there we go, 22 degrees of freedom. And if I want about 95%, I've noticed on the t-distribution I have to go a little bit above 2 standard deviations to get it. And in my Excel, that's what I see here. Okay, so let's get the standard error. The standard error is, again, the standard deviation divided by square root of sample size. As always, put me on pause when I'm using these formulas so you can make sense of them. And if I'm doing a 95% confidence, my margin of error is my t-score associated with 95% confidence times my standard error. Oops, got it in the wrong spot. So that is my t-score times my standard error. Enter. Now, if I want to build the confidence interval, I need a lower bound and an upper bound. So my lower bound is my sample mean minus my margin of error. And my upper bound is my sample mean plus my margin of error. And so now what the police say is that, if we round a little bit here, that we are estimating with 95% confidence that the speed on Euclid Ave is between 29 miles per hour and 33 miles per hour, the average speed. The way to interpret this statistically is in 95% of samples of the same size gathered in the same way, our interval will capture the true speed of cars on Euclid Avenue. We don't know that this particular interval actually captured the true speed, but we think that it's probably pretty darn close. Again, I hope this has been helpful.